Welcome to all in this lecture. This is the second video in the series of partial differentiation. In the earlier video, we have discussed the basic formulas of differentiation, and now in this lecture, we are going to discuss the basics of partial differentiation and some of the examples on partial differentiation. So let's start to the video. So first we will consider if z equal to f of x comma y. Okay, f of x comma y, and here we will consider that both x and y are variables. Okay, are variables. So first condition for partial differentiation is that while we are differentiating with respect to x, we will assume y as constant. Okay, and vice versa, when we are differentiating with respect to y, we will assume x as a constant. Okay, this is the basic condition of partial differentiation. That's why it is called partial, because we are differentiating with respect to one variable and we are assuming the other variable to be constant. Okay, that is the case here. So z equal to f of x comma y. For differentiating z with respect to x, partially differentiation, we will assume as y to be constant. So we get limit delta x tends to 0, f of x plus delta x comma y minus f of x comma y divided by delta x. And for partial differentiating z with respect to y, we will take x to be constant. So limit delta y tends to 0, f of x comma y plus delta y minus f of x comma y divided by delta y. Okay, this is just the definition. In the example we are going to understand it deeply, how to solve it. So let's see an example. So we have z equal to xy square plus y cube plus x square plus 2x square y. Okay, so z is a function of x comma y variable. Okay, and now we have to find the partial differentiation of z with respect to x and the partial differentiation of z with respect to y. Okay, so first of all, for partial differentiation of z with respect to x, we will assume y as a constant, and for partial differentiation of z with respect to y, we will assume x as a constant. Okay, so let's start to solve it. So for delta z upon delta x, find the differentiation of expression. That is, we are going to find the differentiation of given expression with respect to x and take y as a constant. Okay, so this is our expression, z equal to x square plus y cube plus x square plus 2x square y. Okay, so partially differentiating z, we get delta z upon delta x. Okay, so xy square, differentiation of xy square, y is a constant term, so differentiation of x with respect to x is 1, so only we get y square. Y cube, y is a constant term, so y cube is also a constant, so differentiation of a constant is 0. X square, differentiation of x square is 2x, and lastly 2x square y is a constant, so 2x square, differentiation of 2x square becomes 2 to the 4xy. Okay, so 4xy, cancelling this 0, we get delta z upon delta x equal to y square plus 2x plus 4xy. That is, we took y as a constant and solved this expression by differentiation. Okay, take y as a constant. That is the main condition for solving the partial differentiation. Okay, now we have to find delta z upon delta y. So find the differentiation of given expression with respect to y and take x as a constant. That is, we will take all the x as a constant term. We have this z equal to xy square plus y cube plus x square plus 2x square y. So differentiation of z with respect to y is delta z upon delta y. Now xy square. Here x is a constant term. So we will differentiate this y square. So differentiation of y square will be 2y and this constant x. So 2xy we get here. Okay. Now this y cube, y is a variable, so y cube will be, differentiation of y cube will be 3y square. So we get 3y square. Okay. X square, we know x is a constant here, as we are differentiating with respect to y, x is a constant, so x square will be 0, differentiation of x square will be 0. And this 2x square y term, here x square is constant and y is a variable, so differentiation of y will be 1, so we will get 2 into 1 into x square, that is 2x square. Okay, so we get delta z upon delta y equal to 2xy plus 3y square plus 2x square. Okay, that is our answer. So remember, what do we remember? For finding x, for finding the partial differentiation with respect to x, we will take all other variables as constant. As the other variable here was y, we will take y constant. Okay, and for partial differentiating with respect to y, we will take all other variables as a constant. Here the only variable other than y was x, so we took x as a constant. Okay, so now let's solve another example. This is a this is a complex example. Find the value of delta square y upon delta t square, that is, it is the double differentiation, it is the double differentiation. Okay, double differentiation with respect to t, if y equal to f of x plus 80 plus g of x minus 80. Okay, first of all, f and g are functions, are some functions. We don't know what are these functions. Okay, f and g are some functions. Secondly, here x and t are variables. X and t are variables. Okay, and third, that is a is a constant term. A is a constant term. Okay, these are the conditions. What are the conditions? F and g are functions, f and g are functions, x and t are variables, and a is a constant term. So moving forward, we have to find the double differentiation with respect to t. So we will take other variables constant, other variables as a constant. So other variable other than t, the variable is x, so we will take x as a constant term, we will take x as a constant term. That is the condition here for finding the partial differentiation. So moving forward, differentiating, partial differentiating y with respect to t, we get delta y upon delta t equal to, okay, so differentiation of this, so differentiation of fx will be f dash of x. Here x is x plus 80. Okay, so f dash of x plus 80. And by the chain rule, we get d by dt, that is differentiation with respect to t of this term, because it is a complex term, not only x. So we get d by dt of x plus 80 plus. Now this, so differentiation of g will be g dash x minus 80 by chain rule, d by dt of x minus 80. Okay, that is what we get. So here x is a constant term, we know we are differentiating with respect to t, and in partial differentiation we will get x constant, so differentiation of x will be 1. Differentiation x is a constant, so it will be 0, sorry, it will be 0 plus different a will be as it is, and differentiation of t will be 1, so we will get a, so a into f dash of x plus 80. Okay, and here x minus 80, differentiation, x is a constant term, so differentiation of x will be 0 minus a as it is, and differentiation of t will be 1, so minus a, so minus a into g dash of x minus 80. And now double differentiating, that is again differentiating, partially differentiating with respect to t. What do we get? See here, we keep a as it is, here f dash of x plus 80 will become f double dash of x plus 80. Okay, and differentiation of x plus 80 will be into a, so we get a square f double dash of x plus 80. Okay, now this term, okay, minus as it is, a as it is. Differentiation of g dash x minus 80 will be g double dash x minus 80. And by chain rule, the differentiation of x minus 80 will be, as x is a constant term, it will be minus a. Okay, so this minus becomes plus a into a square g double dash of x minus 80. Okay, that is how we get the double differentiation, double partial differentiation with respect to t. So this was our first video in the series. This was our second video in the series of partial differentiation. We solved the basics here and also solved some examples. Thanks for watching.